All right. Welcome everyone. So today we'll continue with quadratic equations, but we'll look on a separate or a different concept. In that concept, we're talking about the symmetrical properties of roots of quadratic equation. And those symmetrical properties are talking about the alpha and beta properties. So now we are saying that if or let alpha and beta be the roots or solutions of the quadratic equation, ax squared plus bx plus c is equals to 0, then the sum of the roots alpha plus beta, or when we add the alpha and beta, we should get negative b over a as its function or as its formula, and the product of the roots alpha multiplied by beta, we get c over a. So now let's look at the general formula whereby we understand how to come up with an equation when we have the roots given. So now let's take for instance we have we say x should be equal to alpha as a solution and x should be equal to beta as a solution. So if we want to come up with a quadratic equation, meaning that we are saying x minus alpha and x minus what, beta, should be equal to what, to 0. Okay, then we expand this one. Now to expand, so we just multiply this x multiplies with that x, we have what, x squared. Then x multiplied by negative beta, we have negative x beta. Then x multiplied by negative alpha, we have negative x alpha. Then negative alpha multiplied by negative beta, we have positive alpha beta. This should give equal to what, to 0. Okay, then we know that this one we can say x squared, we can factor out the negative there, and we know that x is common. We can also factor out the x. We can write in form as alpha plus beta, then x outside there, then plus alpha times beta equals to 0. So ladies and gentlemen, this is how you come up with the general formula that you solve or that you use when you want to find the equation of the quadratic equation given the roots after you solve those roots. Now let's take an example so that we see how we can use the formula. All right, so I was just copying the question. So you have seen that the question we have, we are saying the roots of the equation 2x squared plus 5x minus 2 equals 0 are alpha and beta. Find the equation whose roots are 1 over alpha squared and 1 over beta squared. So how do you proceed? So step one, you get the equation which have been given in the question. So you write the equation which you have. We are saying 2x squared plus 5x minus 2 equals to 0. So in this equation which you have, what you're supposed to do is to get now the sum and the product. So how do you get the sum? So you know that the sum of the two roots which we're saying alpha and beta should be equal to negative b over a. Then we know that from what we know from this function, which you know that ax squared plus bx plus c, we know that this one is for a, then the coefficient of the x should be the b, then the constant is what we call the c. So we know that in this equation which you have been given 2x squared plus 5x minus 2, you know that the b, it should be equal to what, the coefficient of x, which is 5. Now there's a negative there, so it means be negative what, negative 5 over the value of the a, which is saying it's a coefficient of the x squared, which is what, a 2. So that is our solution. Then we need also to obtain the what, we need also to obtain the product. So the product was saying it should be alpha multiplied by beta should be c over a. So we know that c is what, is negative 2 over a is what, is 2. So meaning the product should be what, negative 1. So we are done with getting the sum and the product on the first step. Now what is the second step? So now we are going for the second what, the second step. Okay, so now the second step, now we know that we have been given the roots to be 1 over alpha squared and 1 over beta squared. So what are we supposed to do? So we're supposed to obtain now the product and the sum using the same roots given. So the first you can do, you can get the sum. So how do we get the sum? So we get the sum by saying 1 over alpha squared plus 1 over beta squared. So you just evaluate as you solve just normal fractions. So you are going to find the LCM. So you know that this would be alpha squared and beta squared. Okay, then you divide now. So alpha squared into alpha squared beta squared, the alpha squared will cancel, remain with what? Beta squared. So beta squared multiplied by 1, we get what? Beta squared. Plus beta squared into alpha squared beta squared will be cancelled, then will remain with what? Alpha squared. Okay, this is good. So now here, ladies and gentlemen, you have seen that on the denominator there, it's easy to manipulate there because we know that we have alpha squared and beta squared. So what we can do, so the numerator we can maintain as alpha squared and beta squared there. Then you can also manipulate the denominator by saying alpha beta as squared. All right. Now, there on the numerator, you have seen that we have a function which is beta squared plus alpha squared. You know that this one, we don't have an equation there which we can substitute. So we need to find the equation. So you know that for you to obtain this one, for those who have not watched the previous videos which I've sent, you know that for you to get this one, you just simply say beta squared plus alpha squared should be equal to beta plus alpha, these are squared, should be equal to this means here same as we are expanding this part, because it's like we're going to expand this part. So when you expand this part, okay, let me just lab this one. So meaning that here we're saying that it's beta plus alpha then squared, then you're going to expand this one. So expanding this one means we have alpha plus beta there, then you have alpha plus beta, starting with just alpha. Then you're going to have what? We are going to have alpha squared plus alpha beta, then plus alpha beta plus beta squared. Then we'll have now putting alpha squared plus beta squared plus 2 alpha beta, since these are like terms, should be equal to alpha plus beta squared. So since we have seen that we have obtained what we wanted as alpha squared plus beta squared, we can transpose this one to the other side. Then we're going to have alpha plus beta squared minus 2 alpha beta should be equal to alpha squared plus beta squared. So where we see alpha squared plus beta squared, we need to substitute with this. Okay, all right. So now we can get this one and this substitute where we are saying there is this part of beta squared plus alpha squared, or alpha squared plus beta squared, since we understand that addition is commutative. Therefore, we can say alpha plus beta squared minus 2 alpha beta over beta and alpha multiplied squared. So we can just now substitute, since you have the values of alpha plus beta, you have also the values of alpha beta, the values of alpha beta, you can just substitute. So now we are looking for our solutions. We know that from the alpha beta, so the addition we found was negative 5 over 2. So we put negative 5 over 2 there, then square minus on the multiplication, we had found it was what? It was just negative 1. So we put 2 over negative 1 over negative 1 squared. Let me check if these are the solutions. Okay, so working out this one, we're going to have what? 25 over 4 plus 2 over 1. Then we know we're dividing by 1, which is just the same as itself, nothing will change, because one negative 1 squared it's positive 1, so nothing will change. So we just have the numerator to work with. So this means that our 4 will be our lowest common multiple. Then we say 4 there, we're going to have 25 plus 8. Okay, that is 32, 33 over 4. So that will be our solutions from this point. So that will be our sum. So now let's try to get our product. Since this is our sum, let's try to get our product. So from here now, from this part, we can get our product. Okay, so let's try to just demarcate. So if we want to get now our product, simply it's 1 over alpha squared times 1 over beta squared, which is same as 1 over alpha squared and beta squared, which is 1 over alpha beta squared. Then same as 1 over negative 1, which is squared, which is 1. So our product is 1. So now how do we get the final equation? So to get the final equation, remember what I said. I gave you the general formula which you need to use. So to get now the final equation, the final equation is in the form of x squared minus alpha plus beta, then x, then plus alpha beta. So meaning just replace there. So x squared minus, what is our sum? Our sum would see 33 over 4. So put 33 over 4 x. Then what is our product? It's 1. So to be plus 1. So guys, this is how you come up with sorry I didn't show you, but this is how you come up. I was saying this is the general formula I use. X squared minus, then open brackets, alpha plus beta, close bracket, x plus alpha times beta, then x squared minus, then the sum here. You know that the sum is what you are calculating at first. Remember what you are doing this side. So our sum is basically 33 over 4. So we put the 3 over 4 there, x, then plus our product, which is 1, which we have obtained as a 1 from here. So finally, we can call that this is our equation. So thank you very much for your time which you have spent. So make sure you just you like the video, and also you subscribe for more information and to promote my page. So thank you very much for your support. Continue subscribing for more information. Have a good day.